Yes, I'm biomedical engineering PhD on a mission to make hard science fun and visual. So we created BioniChaos. It's a free platform, playground, for interactive biomedical visualizations, simulations. So for the last 3 years, I've been vibe coding the whole thing live on YouTube. And everything is open source, so feel free to fork it, remix it, or just come hang out while we turn boring data into something chaotic and beautiful. And yeah, the term vibe coding is a bit, I have kind of double mind on it. Yeah, it's more, I probably should stop calling it vibe coding. It's more like pair programming. But yeah, essentially AI agents doing all the work for us. How good is that? Yes, so except AI agents, there is a human in the loop. If you have any questions, happy to cover any of the tools that you see on the site. So we're covering neurological EEG, neurotools, cardiovascular, ECG, PPG, biomedical imaging, MRI. Well, EEG is imaging as well. Vision, hearing, electromyography. Yeah, so a lot of simulations and modeling. Yeah, if you have any questions about the content, everything we do eventually goes freely available on BioniChaos.com. So go check it out, provide your feedback. Yeah, there are games as well. Yeah, go check out the website. Let me know if you have any questions. I have this Boid flocking animation. So it's what's called emergent behavior, where simple rules seem to you like the thing is intelligent or something coming to life. And that was coded by one of the agents quite some time ago, like 6 months ago. Probably these days could do a better job. Yeah, it's based on a paper from 1986, just a single paper given to one of the LLMs. And it's able to do the simulation. Everything's working, no errors. Yeah, that's irrelevant. Error. So yeah, check it out. Provide your feedback. Yeah, I'll read it again. Yeah, we're doing BioniChaos. Everything we do is eventually available on the website, so go check it out. Provide your feedback. Yeah, I have this advanced EEG signal simulator. It has an overview by Notebook LM. Okay, if you have any questions about BioniChaos, do let me know. I'm happy to take any question, especially if you check the website first. Kinda open for feedback, open for business. BioniChaos is biology and electronics combined. Chaos is chaos. See if anything of interest. Check the website BioniChaos.com. This is where everything we develop live. I used to be calling it vibe coding. Probably should not call it vibe coding anymore. It's more like pair programming with AI. And whatever we finish at the end of the stream goes onto the site, goes onto the website for everyone to use for free. It's open source. So we're essentially taking output of LLMs and making it publicly available. So you can benchmark it yourself. They were looking at this EMG hand simulation tool. You have a... Probably should just get AI to explain the tool, which we did a couple of days ago. Yeah, we developed this one 6 months ago, so keep testing. So I'm doing the testing, that's why I'm saying it's probably more like pair programming as opposed to vibe coding. But yeah, let's see. Yeah, if you have any questions on the content, what do we have? EEG, neurotools, heart, ECG, PPG, biomedical imaging, vision, hearing, electromyography. Someone is asking. So I'm a biomedical engineering PhD on a mission to make hard science actually fun and visual. So we created BioniChaos. Everything we do on this YouTube channel eventually goes on to BioniChaos.com as open source tools. So it's a platform for interactive biomedical visualizations, simulations. So essentially we'll be taking a paper or something, turning it into a game, turning it into interactive simulation. Now, I was explaining it to someone else before. So I'm a PhD, which is called a doctor, whatever, but if you're working in biomedicine, biomedical engineering stuff, say you're working in a hospital, you're not allowed to call yourself a doctor because patients get confused. They think you're an actual medical doctor, which is not. So you have to call yourself a researcher or something so they don't get confused. So I'm essentially an engineer, but doing research in biomedical field. Yeah, and if anyone wants to check my website, join me on a stream or something, they're more than welcome, especially if you have interest in biomedical data science stuff. Let's do this review of the website. This is a Notebook LM 10 minutes from a while back, and to summarize what's on the site, and I'll comment along.
Welcome to the deep dive. Today, we're jumping into something really fascinating. It's called BioniChaos.
Right. It's this platform that brings together biomedical data, some really cutting-edge tech, and educational tools in a pretty unique way.
Yeah, exactly. And our mission for this deep dive is basically to unpack how BioniChaos takes these super complex medical and biological ideas.
Things that are usually pretty hard to grasp.
Totally. And turns them into experiences that are, understandable, interactive, and honestly, quite engaging.
Think of it as a shortcut, maybe.
Yeah.
A way for you to get informed about some really complex but important areas in health tech.
We're going to...
The main thing is that no one actually reads papers, or let alone can have a quick look at a data set or even read a description of a data set. So we're taking those papers and data sets, turning them into games, into interactive web applications, making them open source, freely available.
Get simulations where you can peek inside the brain.
And dissect complex signals, navigate these massive medical data sets.
And even touch on some of the ethical questions that pop up.
Yeah, that's important too. Get ready for some aha moments, I think.
Okay, let's start with the brain. Visualizing the signals of thought. BioniChaos has this interactive brain EEG simulation.
Right. And this isn't just, a picture. It lets you actively visualize and explore EEG signal.
It goes deeper too, right, with analysis like PCA and ICA.
Exactly. PTA and ICA, for those who might not know, they're basically smart mathematical ways to find the real patterns and sort of filter out the noise and all that complex brain data.
Makes sense. So it brings brain activity to life for learning.
Precisely. For learning, for demos. And to help with that, there's also the interactive guide to EEG technologies.
Oh. Okay, so this gets into the nuts and bolts.
Yeah, everything from
It's funny how the bot had this weird, as if it's thinking mid-sentence or something. It's something with this is old Notebook LM from 6 months ago or so. So probably have to regenerate those at some stage. But, to me it sounds pretty good already. I could not do any better, that's for sure.
electrodes, where you put them, how invasive different methods are.
And the different brain waves, delta, theta.
All of them. Delta for deep sleep, theta for relaxation, alpha, beta.
Yeah, yeah.
It visualizes how we see these different states of mind. It's key to interpreting those rhythms you see.
Okay, so we can see the signals, but then there's this next tool, the AI-powered EEG speech decoding report. Wow.
Yeah.
I mean, translating brain activity directly into speech, the possibilities just seem huge.
It's a massive leap, really. This report digs into the new approaches trying to make that happen, turning brain signals into actual words.
What's the big insight there, beyond just the tech itself?
Well, I think it's the jump from theory, BCI theory, to potentially practical communication.
Right.
Think about people with severe
BCI is brain-computer interfaces.
speech issues or emergency situations, maybe.
Yeah.
It's about giving a voice back, potentially. That's more than just tech. It's profound. A huge step in how humans and computers might interact.
Absolutely astonishing. And for people wanting to get even more hands-on.
There's the advanced EEG signal simulator. That's where you can customize the brainwaves.
Simulate artifacts, too, those glitches that mess things up.
Yep. Simulate artifacts, see the signals in time and frequency. It's really geared towards researchers, BCI development, that kind of thing.
And building on that foundation.
There are specific tools like Rhythm Scan. This lets you explore real EEG data, visualize things called spectrograms, and understand how machine learning is used for, say, seizure detection.
Which actually leads us nicely into...
Yeah, we haven't touched that one in a while. We actually did some training on open source, open access dataset. So we kind of will be looking at doing more of that. That was benchmarking, essentially results, replicating results from existing study from several years back. And I think we did as good or potentially slightly better than a big scientific study. And this one doesn't have a notebook LM explanation. We can pop it into any bot that will do a better job explaining this. So yeah, if you're a YouTuber making content like this, educational content, you probably, think again. What is it you want to do? But here we're using like a hybrid situation. Yeah, it's funny how AI knows more about the brain than most humans do. How it's interesting, isn't it? As in, AI knows more about the human brain that 99.9% of humans do. That's interesting, isn't it? Yeah, where was I? We did this training. So we trained 18 times, eventually got to a saturated performance. So there you go. And that's AI generated all the Python code for doing the training. So the code, the dataset is open source. The code is available at the bottom of my page. And there's a description of the results. All the confusion matrices and stuff. And accuracy, loss plot. Yeah, so you can see how it's saturating after that many training epochs. And the interesting thing about it is what the code to train was generated by a neural network, a language model. And that's the accuracy you get. Yeah, in the original study, they get kind of similar results. So we were able to match, and I think the results were already quite saturated. But perhaps we were able to do a little bit better. Yeah, so this is on BioniChaos.com. Rhythm Scan. I don't know why it's called Rhythm Scan. Yeah, but it's a EEG seizure detection project. So it's not prediction, it's detection. It's a publicly available dataset from memory. It's 600 images, half with seizures, half with no seizures, spectrograms. And then we train a model to detect which one's which. We show the model a random image. So in theory, when you record more EEG, convert it into a spectrogram, that model will be able, and it's a simple model, it's only like 70 megabytes, about 10 layers. Yeah, here you have it's in the code, it's in the Python code, the description of the, so we're training in 100 epochs. Yeah, you have all the settings of the model in the code there. But yeah, bottom line, it's about 70 megabytes. You can run it anywhere on any device, and essentially give it new brainwaves, and it will determine if you have epileptic seizures or not. And did you know that all the tools we develop live are freely available on BioniChaos.com? It's open source.
Explore real EEG data, visualize things called spectrograms, and understand how machine learning is used for, say, seizure detection.
Which actually leads us nicely into understanding complex signals more generally, not just brainwaves.
Right, because understanding any of these signals, it often comes down to finding the patterns underneath.
So we shift from biology to the math behind it, like Fourier analysis.
Exactly. And BioniChaos has a really captivating tool for this, the Fourier series visualization.
Oh, I think I saw this one. You draw a shape.
Any shape you want, yeah. And then you watch as the tool rebuilds it using a sum of rotating vectors, epicycles, basically.
It's kind of mesmerizing.
It is. And it shows beautifully how even incredibly complex, jagged patterns can be broken down into simple, smooth sine waves.
Which is fundamental to so much, right? Signal processing, sound, images.
Absolutely. It reveals this sort of hidden order in seemingly chaotic data.
I remember when I first tried to learn Fourier analysis, it felt, well, daunting, like math magic. Does BioniChaos help make it less intimidating?
I think so, yeah. That's the whole point of these interactive tools. They have a high-fidelity Fourier simulation, too. It gives you real-time visuals of the signal, the frequency parts, those spinning epicycles. It makes it intuitive, not just abstract equations.
So you can really see the math at work.
Precisely.
Okay, so we have these powerful ways to analyze signals. What about applying this to just the sheer volume of medical data that's out there now? How do we navigate that?
That's a huge challenge, and BioniChaos addresses it with tools like the multimodal medical data landscape, an interactive report.
Multimodal meaning different types of data together.
Exactly. EEG, ECG, imaging, etc.
Yeah, we kind of lost the prompt engineer. But yeah, if you check the site, do let us know what did you make of it. Yeah, so everything we do eventually have available on BioniChaos.com. I pop some links in the chat, so go check those out. Let me know what you think. Provide your feedback. Signal Explorer, so some examples of different types of signals: EEG, ECG, PPG, FNIS. EEG is electroencephalography. So anyway, brainwaves, heart. So those are some simulated signals with simulating stuff with AI. Yes, some Fourier transform analysis. Simulation, so you can turn your drawing into an animation. So yeah, and Fourier transforms are used a lot for biomedical data analysis, so it is relevant. Yeah, we're training a model on the EEG seizure detection. This big data set, 600 images, not big data set, but yeah, it's actually a relatively small data set, but labeled by a clinician, by an expert. So was seizures were marked. So it's like half of a spectrogram images with seizures and half without. We trained the model on that. Highly successful. And the dataset is open source, so you can reproduce the results. My code is at the bottom of the page. BioniChaos.com/rhythmscan. Yeah, we did all the development of this live on YouTube, so there should be some videos that you can look up. Us talking to one of the language models, creating the Python script for it. Next stage for this will be actually deploying the model. It's only 70 megabytes, like 10 parameters or so. So a small model. So it could run in any browser or any device in theory. But yeah, it's open source, so take it, run with it. Yeah, that's nice. Someone is creating a simulation of the universe. We are struggling to train a model on 600 images, and someone goes like, screw that, we'll just make a simulation of the entire universe. Good luck with that. Yeah, so just go check out the site, provide your feedback. There's a human in the loop.